Welcome back to the workshop and welcome to this ongoing series to install this electronic lead screw onto this lathe. So this is a kit that was developed by James Clough, Clough42. I'll put a link to his excellent build series down below. And when I say kit, you obviously got to adapt it to your particular lathe, your installation, make it suit your purposes, and that's basically what a lot of this video series has been about. So unusually I'm recording the introduction at the end, because the original introduction that I made at the beginning of this video, none of it really came true. I had a whole load more problems. Good news is I have finally got it to work. It does all run properly, and I've got a piece in there which I've turned down and I'm about to put a thread on it. So if you want to see all the issues I had and how I got to this point, then keep watching and let's start the video. Welcome back to the workshop and welcome to this continuing video series in terms of installing this electronic lead screw. And at the moment we're just trying to debug it and figure out why it's not showing the correct RPM. So in the last video we worked out that servo was working. I sent some pulses to that and that moves nice and smoothly. The display lights up and seems to work, the buttons seem to work. We did figure out that the 5-volt little DIN rail mounted supply is broken, so I've got this surrogate system down here, so I can run off this 5-volt supply until the new one arrives. And what else we figured out? Yeah, we moved the encoder across from channel 1 into channel 2, re-flashed all the software to take advantage of that. Still didn't work, so I think we need to dig out the scope, have a little look round and maybe investigate some of the grounding, something like that, and hopefully it's as simple as that and we can get it fixed. So let's get going. Okay, I've unplugged the DRO, which means part of that circuit's not working, and we should still get an RPM. And the encoder part should still work, so we've still got the 5 volts plugged in. So let's try that. I think, bottom line, this is to do with interference. So I think this second input is now working, but I've just got too much interference somewhere that's messing something up. So I've got the scope out. If I just touch this onto the 5-volt line that comes from the power supply, that's here. So it jumps up to 5 volts. Just click that in. I don't know if we can look at any kind of noise on that, but I'll tell you what we could do. We could do AC coupling. Where's the channel for that one? Okay. Right, so we're taking the DC bit out now. AC noise, so we can just look at peak to peak, 100 millivolts. So that's half a volt. Yeah, so there is some on there. That's running from that power supply. It's probably 100 millivolts. Okay, so I've got the 5-volt supply on. I don't have the motor on or the DRO on, anything like that. We've just got the lathe on, and then we'll just turn that just as a way to drive the encoder and just see what happens. Okay, we can keep an eye on that 5-volt feed just for fun. Ooh, that's interesting. Let's take the get its trigger properly. Ooh. So that's 0, so that it's about 5 volts, but it's got this horrible ripple on it. I wonder if that's, well, it could be going through the mains, but I've plugged this in on a pretty isolated socket, or it's coming in through the wiring somewhere. Let's put that right down, let's see what happens. It's about as low as it can go. On the dial says 150, so 163, yeah, that's probably about right. If we go up, good news is it's tracking with speed, so that's working. Obviously, I don't like the look of that. Goes away. Okay. So just touch the oscilloscope probe on the earth of the chassis on here, which of course goes back to the earth and goes back to the earth mains. And there was quite a lot of noise suddenly appeared on the scope. And the way I did this deliberately was they give you a screened cable on the encoder. I don't know if you can see that, but the screen that goes around the outside, I made sure it would get caught here where it gets clamped, so it would go onto this earth and then earth through there. So I wonder if the inverter noise is going back through the mains, coming back via the earth and the earth of the chassis, and it's going into there and it's messing up the encoder signal. So I think I'm going to redo this and have it so it's not touching the earth there. I'll just try and isolate that with some tape maybe and then see if that's any better. Right, I think I've got to the root of the problem. So it's not very neat, but just to see if it works, I've got the screen here just hanging out the back with a bit of tape around it so it can't touch this screen here, and then I've got the oscilloscope monitoring that screen. So that's the earth that comes from the mains, and it looks like this on the screen. Yeah, so pretty noisy, and oh wow, 2 volts per or 5 volts per division, so that's nearly 10 volts of mains, well not mains, inverter noise. Right, so I'm now going to turn the DRO off and you'll see what happens, and then we'll turn the lathe off. So DRO off. Yeah, so that's a lot better. So it's obviously somehow coming in through that line. Because I've run out of plugs, I've gone back to putting the DRO next to the lathe one. Yeah, so the DRO I've plugged in here. So yeah, there's a lot of noise coming through the earth, and then that was going through the screen and then interfering with the signals coming through the encoder. So it's kind of like baked in 10 volts of inverter noise and spikes. So you know, I was never going to like that. So yeah, it's actually okay to have these next to each other and have that. You just can't have that earth going through the screen of the encoder. That's what was messing things up. So now, as I can show you, it works perfectly. Okay, so I'll switch that back on. A lot of noise, but because I've isolated the screen from the encoder, it's not going anywhere, it's not doing any harm. We now get a really nice rock steady signal on there, and it runs the motor. Okay, here we go. We've got, let's call it 600 RPM, somewhere around there. We've got our motor running, nice and smooth. Oh yeah, that was really juddering before. That looks nice. Everything's working as it should. Let's try the feed. It's going to go quite quick now. Working. Yes, finally. Wow, that took some work. We got there. Okay, so since we've got this far, we may as well check if I've got my calculations right, or I need to do some more calibration. So I've got my little tachometer here. These are quite cheap off eBay, £12 maybe, and I did experiment with it a minute ago, and somewhere, oh, I'm taking it off again. I did put the reflective tape on here, but it doesn't work very well because it's quite shiny. So I've got it on the end of this dark, like the lock nut. So we'll get the spindle speed there, and I've got another piece of tape down here on the lead screw pulley. We've also got one on here. And now I tried this earlier, and that's definitely pretty much 1-to-1, so that's okay. That was important to get that in the calibration. I managed to get that pulley to be basically the same size as that, so that's 1-to-1, that's good. So let's see what we've got. So we'll fire this up to 600. on here and see what we get, and compare, and then we'll see what we get here, and then I'll do some checks and calculations for that feed rate if that is going the correct speed. Okay, we're now going to just check the calibration of everything. So we'll go up to 600 RPM on the display. I'll use the little digital tachometer. I've got some reflective tape on there to measure the speed of the spindle. You do need something black and then something reflective next to it, so that's ideal. This was too reflective, so I've had to put some black tape on it, and then we've got a little reflective pickup there. Hopefully that's enough, just once per rev, because it might go a bit slow. In fact, I think what we'll do, we'll bump the feed rate up. That's millimeters per revolution, isn't it? So if we make the maths easier, if we go to 1, so if we go to 600 RPM, it's a 2mm per revolution lead screw, so that should do about 300 RPM. Yeah, I think that's right. Right, well, let's find out, shall we? Very sketchy setup. If my power supply gets caught in that belt, or the oscilloscope, all the power cables, that will not be good. Or me, yeah. So try and get to 600. Oh, it's very twitchy. Alright, let's call that 600 there. Survey says 600 point, yeah, oh, ran off. Yeah, it's 600.1. Okay, so that's correct, which means that the encoder is 1:1, and that's correct. It's getting the correct reading. So this should be 300. Try and put it where you can see it. And if you see that, 300.6, jumping around a little bit. 300.5. I would say 300.1.8. Yeah, okay, because that's moving a little bit, isn't it? I reckon that's got it. So I've put the right values in. That's brilliant. You might have also noticed, I can't remember if I mentioned it, but I've also flicked switch number 6 on this to make the direction go the other way, so that's now moving correct. So the carriage should move towards us. In fact, let's give that a try. I'll move it away from the tailstock in case it goes that way, but I think we'll be alright. Okay, here it goes. It's going to move quite quick. Oh yeah. How much power have we got there? Oh wow. That does not want to stop. Yes, finally, very pleased with that. All it took was, I guess these aren't cheap, but aren't they? A moderately priced oscilloscope just to debug it, find out what was going on. It was essentially noise in the outer cable, the grounding cable of the encoder. That was running back to earth, which was running back to the main power supply earth. So, should I try and do something about that? Well, it does seem to be working. I don't know how I could get that noise out, or whether I should worry too much about it. I think the main thing is we need to get that new 5-volt power supply in. I need to fix up the connector that goes into the encoder that I've just bodged together now. We need to clear all this out of the way, and yeah, get rid of all the tape. What else have we got to do? Get the end cover back. Oh! We're going to cut a thread, haven't we? We've got to cut a thread. That's the whole point, yeah. Oh, hang on, before we do that, I guess we better try all the buttons out. Yeah, we know the feed works. What about the others? Okay, let's fire it up. So obviously we know the RPM works. As you can see, with the motors running as well. If we bump the feed up, it's running a lot faster. Yeah. Okay. What else have we got? Inches, millimeters. Well, I guess will it let you do that? No. I guess you have to come to a stop. Okay, we can do inches, millimeters, and we can do feed and threading. That's nice. 0.2, quite small, all the way up to 1.25 or 1.5? No, more 2. I think the gearbox is a little noisy down here in the apron. Yeah, but that's tracking nicely. Not sure what set does. Is that something to put it in memory? Can't quite remember. But this one didn't have the chip on it, the Ep10, I think it was. Ep10. Power? Okay. Okay, that works. Just gives you RPM. Motor's not running. That'd be quite nice. So I know I don't want to run the lead screw all the time. That'd be nice to have a readout of the RPM. Yes. So I was just looking back at that bit of footage, and obviously I'm filming it and I'm discovering stuff as I go, so it may or may not have made logical sense. You know, I was trying to work out what was going on as I was making, recording what I was doing and so on. So just to recap exactly what's going on there. So this lathe has got an inverter at the back, a VFD if you like, and that's down the back behind in a box down here. And that provides the variable speed that runs the motor, so I haven't got to worry about a gearbox or anything like that. I can just vary the speed with this potentiometer on here, and the inverter takes care of the rest. Now that's obviously turning the mains into DC, and then it chops that up and it puts 3-phase, if you like, or 3 phases out that go to the motor, and all that choppiness and all that kind of resynthesis of the signal generates a lot of electrical noise. And in this case it's going down, or it's probably going down the live and neutral, but maybe the filter I put in the box is helping there. But it would seem it's also going down the earth, and then it's going over to the plug over there. So I've got the lathe plugged in there, that's the VFD inverter, so that noise is coming back into the mains and it looks like the earth. And then obviously those are just doubled up, so a single cable comes down, then it splits out into those 2 sockets there. And then that DRO one, well, it's called DRO, but that's the one that goes off to the box over here. So it comes in via this IEC connector here, that goes up to there, through that filter. I think it's just filtering the live and the neutral, but not the earth. And then that goes into that distribution block. That immediately comes back out again through this little cable gland here, and that goes out into the DRO. So when you switch it on and power it up, this comes on, and then the whole unit is also powered. So that powers the 48 volt power supply there, and the 5 volt that supply the different voltages DC that we need. And then as well as that, we've obviously got our earth, so we're earthing the main chassis there from the door, from the main case, and they all go back to the backboard, and that goes out to the earth. Now the idea of that is, in case any live wire touches this case, you won't get electrocuted because it'll immediately ground it and it'll trip the breaker. So you need that, but of course it also provides a path for the noise to come the other way, to come into the enclosure, and a lot of that electrical noise was getting into the earth. And then obviously because the outer screen here was also grounded to that noise was coming down here and was completely covering those delicate little signals coming from the encoder, and it was messing up the RPM. So by not connecting that screen to the ground here, that's completely eliminated the problem, at least for me. So that's what I'm going to run with. It seems to work. See how we get on, but that essentially was what was going on, at least in my system. Right, pleased to have finally got that working, and I think we can end the video there. Fantastic. Aren't you going to cut some threads? That was the whole point in this, wasn't it? Oh, yeah, I guess we better cut some threads, hadn't we? But actually, even before we do that, we'll put the end cover on, make it all safe, and then we'll get it all powered up, and we can get ourselves set up. So speaking of power supply, we're talking about the 5 volt supply there. That's the one I broke in the last video. So I've got a new one on order, no problem. But yesterday I had an email from eBay, or from the seller. They're based in China. It says, thanks for your interest. The customs inform us that the parcel can't be shipped for some safety reasons. So we can't ship your parcel temporarily. To save your time and help you solve the problem soon, it is recommended you can buy it locally, which is more convenient. Well, there aren't that many UK sellers of that power supply, yeah, basically because it's so much cheaper just to buy from China if you don't mind waiting. So they did give me a refund, and then when I checked my eBay account, it said that I had cancelled the order, me personally. So I don't know what's going on here. I imagine they went down to their stock room and found they were empty or didn't have any in their stock, and this is their way out of it. I don't know. I mean, why didn't they just email me and say, sorry, they've checked, they made a mistake, can you give me a refund? Yeah, no problem, all right, okay, it happens. So anyway, I've ordered another one from another supplier, so hopefully that'll be, I think that was one of the few UK suppliers, paid a little bit extra, but you know, I need it, so bit weird, but anyway, hopefully we'll be back with a new supply very soon. Anyway, let's get this end cover on. Okay, this will make it a little bit safer. So as I mentioned in the last video, one of the... Oh! This is different. What's happened here? Yeah, I made that while you were messing about with all the electrical stuff. Oh, thanks for that, man. That looks a lot better. Is there any function behind here? Is there any reason for that? No? Well, let's be honest, the old one looks shit, didn't it? Oh, okay, yeah, I agree. That is a lot better. Brilliant. Okay, well, thanks. You could have painted it. Ugh, some people are never happy, are they? Alright. Right, so I'll get this off, put this nut on, get that back together, and yeah, that looks really good, thanks. Aha, Christmas present. Obviously I bought it and then the wife wrapped it up, but that's how these things work. Looks like he was lazy and he didn't actually form that properly. He's just pushed it round and bolted it in. Don't tell him, but he's made a really nice job of that. I guess the reason for that is we don't have a proper box pan folder, so that third fold would have been impossible. I'll let him off maybe. Though I did see the other day Walker have got box pan folder. If it was 12 inch, 24 inch, can't quite remember. It would be perfect for that. It's about £260, so very tempted. Then if I got that, then that means, yeah, I'm going to be doing a lot more sheet metal work. The other one I made was CNC cut out, and it's a bit of a pain really. What you really want is probably to laser cut it out, so, or plasma cut it. So CNC plasma cutter, I think that would go nicely. It's tools all the way, isn't it? Yes, it is, luckily, and we love it. Alright, yeah. Oh, there it is, yeah, I think he's made a really nice job of that. It's much nicer than the one I made. It sort of went on like that. Just looks a bit more purposeful with the angle, sort of matching this. Yeah, I guess he could have tried a bit harder and had a nice radius, but anyway, certainly a lot nicer. Yeah, if I have to take this on and off, that might be a bit of a pain because I have to undo all those little Allen keys to get to the knurled nut, but that's probably not going to happen very often now. I've got all this integrated in here, speed control, and the thread cutting ability and feed and everything, so hopefully it'll stay on here for quite a while. Okay, now some of you may remember in one of the previous episodes I wired in this little e-stop, and it's a little 16mm e-stop, and basically it just interrupts the 5V supply that goes to the microprocessor. So panic, this is heading towards the chuck or something's happening, you hit that, it will stop the servo and it won't feed. Of course it will still turn the lathe spindle, and I had some comments about whether that was safe or not, and I think I'd been doing a lot of thinking about it at the time. and I came to the conclusion that it wasn't that safe, and I got a much better option. So this came in a while back. I think I showed it in one of the early videos. This is a 22mm e-stop. And this is a little bit unusual in that it's got two normally closed contacts, so it can independently cancel two circuits. So one of them will be for the 5 volts, so the MCU will stop receiving power, so the servo should stop. And then the other one will cut power. That's like the interrupter for the e-stop. I think it was the circuit that goes off to the there's a little relay or micro switch that activated when you took the end cover off. I've completely removed that and I just shorted the wires out. So we'll open those up again. We'll put this into that circuit. So basically we'll have 2 e-stops, both do the same thing, stop the spindle, but this one down here also stops the servo. So we need to take this off, open this out to 22mm, and get this wired into here and into the 5 volts. Right, so let's get this started with this. So the only thing I've got to watch out for is the little connector that's on here. I don't damage it. And also note down which way around it goes. Alright, there it is. So I'll just put a bit of tape on that side so I know which way to connect it. Now this one I thought originally just pulled off because sometimes they're just on a spline shaft, but this has got a bit more complicated. It's got a collet on it and the nut is underneath here. So get the end cap off. That should be that. There we are. So we'll take this one out, open the hole to 22. Hopefully that's going to clear. I haven't really checked that. Yeah, should be okay. Right, see you at the workbench. There we go, 22. Okay, I didn't want to bore you with wiring, but I've just remade these because they weren't really suitable, and then they will go into the e-stop on this side of the circuit. So that'll be the 5 volt side, so that's fine. And then for the other side, we need to get a feed from back here from the emergency stop. So I've just taken this cover off. And then I think last time I was in here, here they are. Right, now annoyingly, these were quite long, so they went out to, there was a switch back here for the cover release, so when you took the cover off it would stop the lathe, or you couldn't run it with the cover off basically. And I cut those short, so they clearly aren't going to reach down here to the front, so I need to extend them. So we'll take it out of here, and then I'll just put some little bullet extenders on there and bring it through underneath the lathe spindle, clip it down out of the way so we don't have any problems there, and then we can get it into that e-stop. Alright, let's take that off next. That'll do nicely. Okay, so these come off. If you pull hard enough you can get those out of there, so I'll put that back in the box. And I've got these little crimp connectors now. should do it. Right, need another one of those. And in case you're wondering, yes, I could have used one of these, which are the lever type. Just put your cables in there, push those down and basically make that connection, but I felt on this occasion we're basically extending them and this felt like a better solution, but you know, I'm sure they both work. Also a bit limited on space down here and these are slightly more compact, so I went with that. Okay, I've got this little bracket here. Well, first off, to keep all the cables away from the spindle, because this actually rotates when this goes round. I don't want that rubbing through. And the second reason this is the potentiometer cable, so I'm just trying to keep a little bit of distance because all the mains power that runs to the inverter will go through here as well. So just try and keep those separate. And then the earth is also on that side as well. Just do my best to keep those apart, and then I've just got to make those connections into the back of the e-stop, and then so that's the 5 volt, and then that's our mains ones. So let's get it back together. The other thing I've done, I've drilled another hole through there because we need to reinstate the earth, because now we're going to have live around this metal cable, or this metal plate, sorry. And so if anything happens, that should trip the breaker. So we'll get all that back together, and then that should be this bit done. We'll test it out, of course, but yeah, that should be the e-stop sorted out. Okay, we've got everything wired up now, so got our 5 volts across there, mains across there, our potentiometer there, earth, and the display connector. So I just need to put the potentiometer back on. And there it is, all back together. I must say, I think that looks quite smart there. It's not too close, you've still got your speed control, and in an emergency, yeah, it's pretty solid on there. That should do the trick. I've got my earth reinstated as well. I've got all this information on there. Obviously I don't need the change gear information, but it's nice to have that on there because it just reminds you of all the popular pitches anyway, from 0.2 all the way up to 3.5. Wow, that's quite a pitch, isn't it? I don't cut imperial, but if I needed to, we've got those down here as well. Right, so I think if we're going to try it out, test if the e-stop works and try everything out, I need to put that temporary 5 volts power supply back in, so I'll just have to jam it down there, hook it up to the box, and then we'll try out the e-stop and make sure it all works, and check we've got a good earth and things like that. Is it going to fit? Right, before we switch everything on, we're just going to do a continuity check. So we've got the earth pin there. Nice. No, that doesn't fit. Okay, happy with that. Switch everything on. Just unplug this, make sure we're definitely got 5 volts. Yeah. We're out to CN. Looking good. Okay, we've got lights on everything. Lights on the booster board. Okay, we've got lights on that, but we're not using that 5 volt 48. Lights on there. Right, let's try out the e-stop. Right, let's make sure that's tight. Oh, let's switch it on. That jump in? A little bit. Well, let's see if we get the feed to work. Right, let's engage the half nut. It's going. Can we change the feed on the fly? Oh, we can. 1 amp, so we press this. Okay, that's stopped. Just realised, so because I'm running it off that power supply directly, the e-stop that would come up here is not being used. Okay. Alright, well, we can simulate that by, I'll just pull one of the connectors for the power supply. So it'll do that when the stop goes in. Okay, well, yeah, half works. Let's plug that back in. And we're back. All right. And those back on. It was half a test. Okay, I think when we got that done properly, we'll try that again. But yeah, looks good. Very pleased with that. So thank you for all your comments on the e-stop and making me think a bit more. I think this is a much nicer solution. That's a nice big e-stop and it just kills everything, which is a bit more logical. So yeah, pleased with that. Okay, so some of the fixings have come in. So I've swapped out the M4 cap heads for these button head ones. So all this plate are done, this plate, the gear change plate down here and the switch plate, they're all done. The other thing I've done is swapped out the cap head screws for these M5 button heads, so they're a little bit nicer. Yeah, so I'm really pleased with how that looks. Okay, so the new 5-volt power supply arrived, so I took the old one out. I had to make a few changes because the entry points to the new one are a little bit different. But as you can see now, I've got that installed, switched on, and I've just adjusted using the little screw there till I get 5 volts, and as you can see, everything's working nicely. So we're back to where we were a little while ago, but now it's all working, looking neat, wired in, so hopefully good to go. So as an overview of the whole thing, that's what it looks like now. So yeah, looking pretty good. So I think we're about ready to do some testing. Okay, well as you can see I've got a test piece in there, and the idea was I was going to try the different feed rates just to try and turn it down to a nominal M8 size and then cut an M8 thread. Yeah, that's the whole point in this. But as soon as I turned it on and then got the RPM up to something reasonable, it was just jumping about all over the place. So I got this little reflective strip on there, measured the RPM here, and it was nothing like that. It was still having problems with it. So I just shot a whole load of footage where I took everything out. So I was all the way back down just to the 5-volt supply, and then running the microprocessor, and then building it up and adding more components, and then finally switching on the lathe. And I found a couple of things that are connected that really made the RPM jump around. So let me bring you over to the control box and I'll show you where I'm at and what the plan is. So as you can see, I've got it all stripped back out again. So I started with just the 5-volt supply running the microprocessor. That seemed happy. It ran the display and I could turn the lathe by hand and get a steady speed. I then slowly introduced different components. So I introduced the 48-volt supply, but with the fuse pulled initially, so it was just running. Then I slowly introduced different items, so I put the 48-volt supply on, but initially without the fuse in, so it wasn't driving the motor. Added that, added the fuse in, and it wasn't until I added, there were 2 components. Yeah, one of them was the fan at the top there, so that runs off, it's a 5-volt supply fan, and that runs off the power supply there. And the other one was, there's an emergency stop system on here where it takes the 5-volt signal and the cable goes all the way down here, through to the machine and to the emergency stop on the front, and then it comes all the way back here, assuming that contact is made, and then it powers either the fan or the processor. So when I introduced that loop, I got quite a lot of noise, and when I introduced the fan I got a lot of noise as well, so the RPM was jumping all over the place. Good news is though that if I have the 48-volt supply running and running the stepper, that's okay, or the servo, sorry, that's okay. I haven't put you see the filter's gone, which I did have on the side here for the mains power supply. I haven't put that back in yet, but it's working okay without it, so I think I'm going to keep it simple for now. Just have the mains coming in, it goes back out to the DRO, and it also goes out to feed the 48-volt supply and the 5-volt supply. So I think I'm just going to leave that as it is, and my plan is then as follows. So I think what I'm going to do up here is take all this out, just have my 5-volt supply. I'll feed it via just an inline fuse, so I've got one of those on order that will just go in the cable itself. That will come in the top and go to there, and then the 0 will come back, and that's it. So I want to keep that line as short as possible, away from any noise, not through the lathe, and then I'll just have a little inline fuse, so it's not even go through terminal blocks. So just as short as possible, and then also I won't be running that fan. So I'll take the fan out and just have that as a hole with a grill, and then the cooling fan that comes out of there blows that air from the power supply, because that's the main thing that will get warm in here. I'm sure that will just find its way out there, and there's a hole at the bottom for the air to come in. So I'm going to sort of do semi-active or passive cooling on it and not run that fan. I think that was it for that side. For the main supply here, I'll just see how we get on without the filter that was inside here, so I'll just run the main straight in. The 48-volt supply down to there and the servo and everything seemed to be okay and didn't seem to cause issues, so I think, well, I've got to run that like that. I haven't really got any choice, so I think that's my plan. Okay, and a few minutes later it looks like this. So I've got, what modifications I made? Yeah, so the E-stop doesn't come to here anymore, I've just cut that off. So the E-stop that comes from the machine down there, the 5-volt side doesn't do anything. We'll still stop the 240 volts, so it'll stop the spindle, and the spindle stops, so the encoder will stop, so the servo should stop, so the carriage will stop. I think we'll go with that logic for now. I could put a relay in from that, but if I power it from the 5 volts, then I'm back to square one. I'm interfering with the 5 volts. I could power it from the 48 volts, put a 48 volt relay in here, interrupt that supply, which switches that out, and then the connections make or break the 5 volts. But you know, I've got more wiring. Am I going to have a problem again? I don't know. I think we're going to leave it like that in terms of emergency stop functioning. For now, I've just got the 5 volts going straight out there, straight into that little connector. I've got an inline fuse coming, so I'll put that in when that arrives, but for now I think that's okay. The encoder that runs up there, that's as before, except around the outside there's a screen, and I'd ran that screen. I forgot I'd done that. I had an extra cable. This cable came off the outer screen there, and it went back to earth, and as we now know, there's a lot of noise from the inverter that comes down to the earth, so I've cut that off and running without that, so it is screened, but the screen doesn't go back to that earth there, which we know is very noisy. What else have we done in here? Yeah, so I don't have the earths running around the top anymore. They all come in underneath over here to sort of keep them out of the way. As mentioned before, we don't have the filter in. I'm not sure that was doing anything, to be honest. I'm not sure it was giving a problem, but if it runs without, then we'll leave that out. I think less is probably more in this case. What else have we done? I think that's about it. Oh yeah, I've obviously cleared all the terminal blocks out, and that's allowed me to move it along, so it's sort of halfway between this wiring and this other power supply here. So let's switch on, run the spindle up speed, see what the RPM's like, see if it fluctuates or if it's stable. Hopefully it's stable, and then we can cut a thread. Well, so far so good, because I did last time notice this jump between like 0, 1, and it would sort of flicker between the two. Now that seems to be rock steady. Alright, let's switch on, see what RPM we get, and then we'll check it on here. Oh, there's a bit of something there. Alright, might let that go. 506. Pretty good, 506, let's go for a bit. $671, yeah. $860. You know what, I think we might have cracked it. $992, $992. See how steady it is. Right, looking good. I think we can probably only play with the feed here. Switch on. Let's make sure the other controls work. So, yeah. We just do RPM. Let's have a look. There we go. I think we got it. I think we finally got it. Yes. Okay, I think we're ready to try the feed mode then, so we'll start it back up again. Yeah, we'll keep that feed rate there, engage the half nut, and the carriage should move towards there, and then we'll play around with the feed rate and see what we get. And we can also try the cross slide as well, because it's got an automatic cross slide on this one as well. Right, let's give that a whirl. RPM steady, it's feeding nicely, and we can see on the DRO it's heading towards the chuck, towards certain doom. Okay, let's try up in the feed rate. Okay, we can try the cross slide as well. It's moving. Right, let's clean up that end, bring it down to size, and then we can put our thread on it. Let's take some cuts. Oh, maybe not that fast. Let's try it a bit slower. Okay, I'll just mic that up, put that reading into the DRO so we know where we are, bring that down to the final size. This is an M8, so we want to go to about 7.95, that'll be okay in aluminium. If it was steel, probably go a bit further. We'll put our thread gutter in there for the tool to drop into, get the threading insert in, set this up at the right angle, and then cut our threads. So I think we'll cut a coarse thread, M8 by 1.25. So that's between each crest of the thread will be 1.25 millimeters. That's a standard coarse pitch, and then we'll check a nut. Oh, I've got some nuts, and we'll try see if those fit. Right, I'll bring you back in a minute when we've got the right size, and we'll cut to the exciting bit, which is, does it work? Okay, so we'll put a cut on the top slide. give that a try with the nut. Oh yeah. Well, that's definitely an M8 by 1.25. Pleased with that. It works. Yes, we finally got there. Building my own enclosure, working out how I was going to mount it all, getting the server installed, making the cover plate, getting this installed, the e-stop, all the changes to the control enclosure, debugging it, getting rid of all the electrical noise. Finally, it's come good and I can cut these threads. Also, it's really nice just to be able to quickly switch between the different pitches and then the different feed rates without having to mess around with the change gears. Just dial it in at the front and away you go. So I'm not going to cut a range of threads, I'm sure it works, but what I'm going to do is just verify, just to the dial test indicator, that when I turn the chuck round once, we get the amount of movement we expect on there. Okay, so I've got DTI down there, and that's monitoring the movement of the carriage. And then up here you might be able to see you've got this Allen key, and it's just pointing at the start of that tape, so we know when we come one revolution where the beginning is. And then I've got it set to 1mm on the feed rate, so in theory one revolution should give us one turn on there. Watching on mark. So, there. Yeah, looks pretty good. Okay, we'll try. Right, let's try 0.2. Let's go the other way. So keep the maths easy. We're about to. Let's try that. Okay, 0. Let's give that a try. Okay, it's gone round once. Somewhere here. Right, this time I'll stop when this is aligned here. So it's about there. Yeah, pretty much on it. Okay, so pretty happy with that. I think let's just whiz it up and down and just try some of the feeds. Okay, so we'll go into feed mode. We'll start low and take it from there. Okay, that's pretty slow. Speed up a bit. See the handle coming round. Reverse works as well. That's maximum 1. I guess there's one last thing to try, and that's the emergency stop. So we'll put some feed rate on. Forward. And here we go. Obviously there's a little bit of overrun there, and we are relying on the encoder to stop, and that to stop sending pulses, because technically the kind of encoder and servo side of the system is still engaged. So I guess actually if I manually turned that, yeah, it is still trying to advance the carriage there. But I think in terms of getting rid of the electrical noise, that was the only way to get that to work. I'm pretty happy with that, so I think that's what we'll go with for the safety system. So I guess all that's left to do really is just sum up my experience with this, and just how pleased I am that it's finally working, and the things I can do with it, and how much time it's going to save. So yeah, there was quite a lot of time invested in figuring out how I was going to make it work for my system. There were different options about where to put the servo. Maybe I'd put it on the other end, maybe try and bury it somewhere in there, but I couldn't really get that to work. In the end, I went with one of the viewers' suggestions, so thank you very much for that. I don't think it looks too bad there, sticking out the side. Obviously, if you're thinking about doing something similar, you've got lots of options to consider. Yeah, the electrical noise, that was quite a big one. I don't think James had too many issues. I don't remember him talking about that much. I don't know if it makes a difference if they're on 110 over there, if that changes the volts and the current relative, and we're 240 over here, or 230 in the UK. But anyway, I managed to sort that out, and the system is working really well. So yeah, I think that all that remains to be said is thank you very much for watching. I hope you've enjoyed the series. Leave us some comments if you've had experience and got yours finally to work as well. I know there were a lot of comments about people having electrical noise, and that didn't make me feel quite so bad. I wasn't quite alone, but we got there. If you're following this along and you're behind but you're building, hopefully this has been useful. I know I've had a lot of comments from people who've said this project has been helpful for them, so great. That's the idea, putting it out there and sharing it. So yeah, thank you very much for watching, and yeah, see you on whatever the next project is. I've got a few in mind, don't know which one it's going to be yet, but stay tuned for that, and we'll see you then.